In this video, we're going to be talking about multiplying binomials. So a binomial is anytime we have two terms. It's a polynomial that has two terms. So something like 3x plus 1, that's a binomial. X minus 4, that's a binomial. So if we're going to be multiplying binomials, an example of that would be x plus 3 times x plus 2. So this first problem, I'm going to go through a visual of what this actually means. Using algebra tiles, x plus 3 times x plus 2 would be represented like this. I have an x tile that is x along this side, and this side has a length of 1. And then I have 3 unit tiles, so 1 and 1 and 1. On the other side, I have an x tile with a side length of x and a side length of 1. And then 2 unit tiles. So this is my x plus 3, and this is my x plus 2. When you're going through and multiplying, I'm essentially figuring out the area or the rectangle that is formed. So when I'm multiplying this x tile times an x tile, I'm going to get an x squared tile. X times x is x squared. Then, when I'm multiplying this 1 by this x, I'm going to get an x. 1 times x is x. Same thing here, and same thing here. Now, when I look at the other side, I'm multiplying this 1 here by this x tile, giving me an x here and an x here. Now, to finish off this rectangle, I'm going to have a 1 times a 1, and then again, and I'm going to fill in the rest of these because these are all 1 unit times 1 unit. Those are all 1s. So now when I add everything together, I have an x squared. I have 2 x's here and 3 x's here for a total of 5 x's. And I have 6 unit tiles for a total of plus 6. So multiplying these binomials gives me the product, or the product of these gives me the sum of x squared plus 5x plus 6. So this next example, I'm going to do without algebra tiles. I'm going to use a generic rectangle. And the reason why we call it a generic rectangle is because I don't necessarily care how long the sides are. I'm just going to divide one side into an x plus 5. And I'm going to divide the other side into an x and a minus 1. I'm not going to make the side that's 5 any bigger than the side that's negative 1. I'm just going to make it any general size, so that just a generic rectangle. But now I'm going to be doing the same ideas as the last problem. So in the last problem here, I had an x squared, or an x times an x, giving us an x squared. And that's what I have here as well. An x times an x will give me x squared. A 5 times an x will give me 5x. An x times a negative 1 will give me a negative 1x, or just a negative x. And a 5 times a negative 1 will give me negative 5. So the solution to this, or writing it as a sum, is now combining all my terms here. I have an x squared. I have a total here of 4 x's. Those are like terms, so 5x plus a negative x will be plus 4x. And then I have my negative 5, so minus 5. So multiplying those binomials gives me x squared plus 4x minus 5. My last example, 3x minus 2 and 5x plus 6. If I tried building this with tiles, this would just get really huge because I'd have to have 3 x's, and then I'd have my negative 2, and I have to have 5 x's this way, and it would just get really large. So instead of doing that, the generic rectangle makes this problem much easier. 3x minus 2 and 5x plus 6. And now I'm going to just multiply the sides together to get each box of this generic rectangle. 3x times 5x is 15x squared. Negative 2 times 5x is a negative 10x. 3x times 6 is 18x. And negative 2 times 6 is a negative 12. That means when I multiply these binomials, I'm going to get the sum as 15x squared. Negative 10x and 18x will give me a total of 8x. And I have negative 12 for a minus 12. And that is using generic rectangles to multiply binomials.